Today we're going to be working on Leetcode question number 307, range sum query mutable. Given an integer array, nums handle multiple queries of the following types. So we're going to be updating the value of an element in nums and calculate the sum of the elements of nums between indices left and right inclusive. So we have done a very similar question, not really similar, very similar question, but we have done a question where they were where things were immutable, weren't changing, and we didn't have to do any update, and we were able to actually implement an algorithm where the sum range was O of 1, as we were taking O of n time in order to update the in order to initialize the array. But this time we're gonna be making use of, so let's read it first. So basically it initializes the object with the integer array nums. The update updates the value of nums of index to be value, and the sum range is just gonna return the sum of the element of nums between the indices left and right inclusive. Okay, this is like a typical example or the perfect like use case of the segment tree node, and we're going to be using segment tree node. In the reason for that is like that the segment tree node is allows us to be able to implement this sum range and update both of them in log of n. Because it's going to be a tree node, it's a little bit different. We, instead of like having the binary tree node left and right nodes, we're gonna save the information about the sum of the all the nodes on the left side and all the nodes on the right side, and then the start and the end. These are the few information we're gonna keep in the segment node, tree node. Okay, we're gonna initialize. We're gonna define our segment tree node first. So the segment tree node has int start and end. Then it has few nodes called segment tree node left and right, and then we have the last thing we have is the sum. Okay, the way the constructor is gonna work is the segment tree node takes two things, which is the start and end, and then this dot start is gonna become equal to start, this start and will become end. Okay, and we're gonna set both left and right to null. This dot left equals to null, this dot right equals to null, and we're gonna set the sum equals to 0. Nice. Okay, and also we are going to say that the root seg is also, so that the root is accessible by all the functions. So we're going to call it segment tree node root, which we're going to initialize to null. Okay, nice. So the first thing we're going to do is when we are initializing it in the num array, we're going to say that we're going to change the root, and the root is going to be changed, and we're going to call a helper function build tree, where basically we're going to be sending him the nums and the starting index and the ending index. So the starting index is going to be 0, and the ending index is going to be the nums dot length minus 1. Okay, now we have to implement this function which returns a segment tree node. It's called build tree. It takes int nums, it takes an index, starting index, and an ending index. Okay, how we're gonna be building a tree is by recursion, right? And there are two things here. First of all, there is a sanity check. you can say that if the sanity check, or like the base case too, where the start becomes greater than end. If that is the case, we're just going to return null. I will say it's kind of a base case because start will become end a lot of bigger than end, and we're going to be keep returning the nulls. Okay. Else, if that is not the case, right, then first of all we want to create the the return segment tree node, which is basically a new segment tree node. It takes nums. Okay, sorry, because the segment tree node just needs a start and an end. So we created a new one, but now we want to do two things. One is that the start becomes equal to end. If that is the case, right, we so look at that one. So because the leaf nodes of this tree are always gonna be individual elements where the value, where the sum is actually equal to the value of that nums at that particular index. So it's not gonna be sum of two nodes, it's just gonna be the that value. So for that we're gonna say that the return dot sum equals to nums and start. This is gonna be mostly the leaf nodes. Else, if that is not the case, we're gonna calculate the midpoint. We are worried about the overflow, so we're gonna say start plus end minus start divided by 2, just to avoid the overflow. Okay, now the return is gonna have a left node, right? For that we're gonna recursively call this build tree with the nums and with the start, and it will end at mid. Similarly, we're gonna calculate the right node, where it's gonna be build tree, the nums and the mid plus 1, and then the end. So we have the left and then the right. Once we come out of this else, right, we can just return the whether if or whether else. We can just return that node. Okay, that should be it for the initialization. Now we're going to be implementing our update and some range functions. Update is we're going to be using a helper function with a different like in the definition type of the root. We're going to be calling the same update, but this time the arguments are going to be root and then index and then the value. So this function is going to be again returning a void update, but it takes a segment tree node root and then the end position and then end value. Oops. Okay. So now for this one, yes, we are trying to update it, right? So basically, what if where the root is, the start and the end is exactly the same. If the root dot start is equal to root dot end, that means we just wanna say that the root dot sum is equal to the new value. Else, again, we need to first of all we need to know, are we going to the left side or to the right side? For that we're going to calculate the middle point. That is going to be equal to root dot start plus root dot end minus root dot start divided by 2. Okay, so we found the midpoint. Now if the mid if that position, like the index he is talking about, is less than, if that position is less than equal to mid, let me just do this. Okay, if that is equal to that, then we're gonna call this function root dot left, because we're going to the left side, and then the position and the value. Else we're gonna go to the right side, update root dot right, same position, same value, right? And once we come out of there, we're just gonna say that the root dot sum is basically equal to root dot left dot sum plus root dot right dot sum, and that should do it. A very similar approach is gonna be here for the sum range. We're gonna be using a helper function with the same name but different argument, sum range. That's called root left right, and we're gonna we are going to, but this time, okay, let's just call it, because we are gonna returning the value, that would be okay. So we are returning an int here, and sum range segment tree node root int left int right, or let's just call it start and end. Okay, so what we're gonna do is, first of all, we want to check that if our root if the root dot end is equal to n, and the root dot start is equal to start. If that is the case, we're just gonna return the root dot sum. That's what we're looking for, right? Sum from the starting and the start, from the index start to the index end. Okay, so the root dot sum. If that is not the case, again we either need to go to the right or to the left. For that, we're gonna be calculating the midpoint, which is gonna be equal to root dot root dot start. Wait one second. Root dot start. Root dot start plus root dot end root dot. Okay, so we calculated the midpoint. If the end is less than equal to, again, the midpoint, now we're gonna say that the return sum range is the root dot left and then the start and the end. So the start and the end stays the same. The only thing is that we are going to the left side of it. Again, else, so sorry, we need to say that the else if is equal to start is less than equal to mid plus 1. If that is the case, we're gonna be going to the right side, return sum range root dot right, and then the start and the end. And lastly, if if that is not the case, like if the end is less than equal to like if end is less than equal to mid, we're going to the left side, right? If the start is greater than equal to mid plus 1, we're going to the right side. But if we have like have so so that was like we were out of range on one side. That's why we just completely went to the other side. But now the left side, if that is not the case, right, then we have to actually explore both of them. So all we have to do is to return some range root dot right, and then mid plus 1, and then the end, plus now we're gonna go to the left side to some range root dot left, and then this time it's gonna be start, and then go to the mid. Okay, let's see how it does. Okay, that is over here. Root does not RIGHT. Now it is just not working right now. Okay, we gotta figure this out. Okay, let's see all the conditions here. So when we are initializing, and then the build tree is gonna say that when the start is greater than n, we are sending the null, and the segment tree is one more time. What was the error? So yeah, even before that, even before we updated it, it threw an error. So let's just look at the build tree first. So we are the condition is the start is equal to n, and then we are returning the start, and then this is good. Okay, over here one thing which I noticed is like we are not updating that. So the return dot left dot sum plus return dot right dot sum, just like we did it over here. One thing is that we missed that. Let's see how it does for the other test cases. Yep, and it works.